this number has to be given to you. This is what you actually produced maybe in the lab or something. Okay, so I should have gotten 18 grams. I only got 14 grams. So how do we quantify how thoroughly a reaction goes to completion? What we're going to do is calculate what we call percent yield. And that will tell us the extent to which a reaction has converted the reactants to products. So the equation is actually quite simple. Percent yield is the actual yield. Now this number has to be given to you. This is what you actually produced maybe in the lab or something. And you weigh out your actual product. And then theoretical is what you calculate. Okay, so that is what you calculate you should produce from your limiting reactant. Now, you can't get a percent yield greater than 100%. You know that. So if you got more than 100%, there's a situation there. So let's do an example here. I've got 6 grams of hydrogen and 16 grams of oxygen, and they're going to produce water, and we actually got 14 grams. So how do we find percent yield? Well, first thing we have to do is find the limiting reactant. So I'm going to take both of my quantities of reactants and figure out which one's the limiting reactant. So first step is convert your grams into moles. Okay, and then let me do that the same thing here for oxygen. And that's our friend molar mass. And then I need to do a mole ratio. Let's get that off of the reaction here. So let's trade in moles of hydrogen for moles of water. And that comes from those coefficients. We'll do the same thing down here. Moles of oxygen, get rid of those, and go to moles of water. Sorry. Water up here. Okay, so we're going to get moles of water twice. So I'm going to write my big OR here. So this is calculating limiting reactant, which we just did in the last video. So let me get the rest of my coefficients here. 1 oxygen and 2 waters. Okay, and I'll fill in my molar masses, 2.02 and 32. Oh, sorry, that would be moles of oxygen, grams of oxygen. All right, so what we've done here is we have masses of our reactants, convert them to moles, and then get them both to moles of water. How many moles of water could we produce from those quantities of reactants? Okay, and you're just going to work your, use your calculator here, units will cancel, and we'll be left with moles of water in both cases. And so I get 5.9 on the top, and then I get 1.0 on the bottom. Now, don't leave both of those. Remember, we're going to cross one of them out. Which one can't happen? The bigger one, right? That cannot happen because we will run out of oxygen. Oxygen is my limiting reactant. We will run out once we get to 1 mole of water. Okay? So guess what this is right here? This is our theoretical yield once I convert that guy into grams. So what is 1 mole of water? Well, it's the molar mass of water. We've got 18 grams is the theoretical yield. Okay, so I've got my theoretical yield, and then I've got my, what is this? Actual yield. Okay, so I should have gotten 18 grams. I only got 14 grams. So let's go over here to the next page and calculate the percent yield. Okay, so that is the actual divided by the theoretical times 100. So I actually got 14 grams. Theoretical was 18. And that would give us 78% yield. Okay, so again, percent yield is going to always be less than 100% or equal to. It comes from the actual, which has to be given to you or you get it in the lab, divided by the theoretical. That's the one you calculate based on the limiting reactant. I hope this helps. You can do chemistry.